Hi, I thought I would do the example in the PowerPoint from section 7.2. I made bigger copies so it's a little bit easier to see. So if you flip through the pages, we're going to start about how to do this on page 10. It starts on page 10 and then it kind of goes from there. So what we're going to talk about is how to solve a system equation with three variables. What we're going to do is we're going to, first of all, reduce the two equations into two variables, and the way we do that is we basically eliminate the same variable and we use addition method to do that. Okay, then we take those two equations and then we solve either using addition or substitution method, and at that point we'll have actually a value of one of the variables. Then we back substitute to find the other variables, and then of course you check your answers. Okay, so I was going to do the next one in the PowerPoint. I was going to kind of put some more steps in here beyond what they have in the PowerPoint. So this is one of the problems in the PowerPoint. It says solve the system of linear equations with three variables. There we go. Okay. So I thought this would be a good one to do and just give you a little bit more information beyond just the PowerPoint. Okay, so the first thing you want to do is decide what do you want to eliminate, X, Y, or Z. You can actually eliminate any of them, but what they did down here is they eliminated Z because it looks like that's pretty easy to eliminate because these are already opposites. And then I can, multiply this by 2 to get the opposite of that one. Okay, so I labeled this equation 1, this equation 2, and this equation 3. So they eliminated Z twice. The first time they did it was equations 1 and 2. So if you look, they rewrote equation 1 and equation 2 right here. And the reason why they did that is because these are already opposites. So they went ahead and added them together, and they got this equation. Okay, then they eliminate Z again. Okay, this time they use equation 1 and equation 3. So if you look at these two, to make these opposites, what they did was they took this whole equation and they multiplied by 2. So again, this whole equation multiplied by 2 gives me this equation right here. I put 2 times equation 1. And then they wrote equation 3 with it. Okay, and we add these together again. We get 4x plus 5y, no z's, the z's subtract each other out, is equal to 24. Okay, so that's another new equation. Okay, so far we've eliminated one variable. Now we have a system of equations with just two variables, so it's a little bit easier. Okay, so I'm going to go down to the next page here. Okay, these are the two equations that we just did a second ago. So now what they decide to do is, what variable do they decide to eliminate? They decide to eliminate x. I'm going to actually write that here. And the way they did this is they used the addition or the elimination method. You can also use the substitution method you prefer. They eliminated x. They wanted these to be opposites, so they rewrote this equation. And they took this equation times -1 to make that -4x. So I take -1 times this equation to get this equation right here. When I add these together, the x's cancel out, and I get y is equal to 4. Okay, so now we have one of the variables. We have y. Okay, now we have to go back and find the other ones. So what I want to do is plug this back into one of these equations and find x. So I'll show you that on the next page. Okay, they took the first equation. They plugged in 4 for y. Okay, so here's the first equation. Plugged in 4 for y, and now we have x. So now we have x, and now we have y. The last thing we have to do is find z. To find z, you could plug into any of these equations. Plug in for x, which you already know. X is 1. Plug in 4 for y, and then find z. Again, you can use any of these equations. It looks like the one that they chose was the very first one. So I'm going to show you that right here. Okay, so here's the first equation. Again, you can use any of them. They plug in 4 for x. I'm sorry, 1 for x, 4 for y, and we're trying to solve z. And so we get our last solution. So kind of going back here. X is 1. Y is 4, and Z is -3. Okay, so that's the end of that example.